Hey, tech viewers, what's up? What's happening? How you doing, guys? Let's do a quick activity, shall we? So click on an empty space on your desktop and now hit the following key combination. Ctrl-Shift-N. Great. Now type in these letters. ALGORITHMS. Now press enter. Voila! You've now created a new folder on your desktop called Algorithms. And yes, you have just executed an algorithm to create a new folder. Congratulations. But wait, what is an algorithm? Let's explore that in a bit, shall we? Welcome to Tek-View. This channel is dedicated to providing you with relevant tech content, particularly in the areas of programming, data science, machine learning, artificial intelligence, multimedia, and all the cool stuff you can find in IT. So if you haven't subscribed already, kindly subscribe to this channel. Click on the bell icon to be notified each time I release a new video. This video is the first of many in a playlist I've created on programming with C++. For my returning subscribers, thank you so much for your support. I appreciate you. Don't forget to like this video and also to share. I'm EJ. Now let's demystify algorithms. Are you ready? All right, let's go. Whenever you have a set of instructions that you're supposed to follow in order to complete a particular task, you've got yourself an algorithm right there. Yeah, it's that simple. Now, for the sake of those who are writing exams, you can formally define an algorithm as a finite set of instructions which are supposed to be followed in order to execute a particular task, right? Cool. Yeah, but like God, algorithms have different names in different domains, different names, different domains. Yeah, I feel like I'm rapping, right? Maybe I should focus on my rap career and dog that boxing. What do you think? Let me know in the comment section. Yeah, so you would normally refer to the set of instructions you take in preparing your favorite meal as your recipe. Let me know what your favorite meal is. I'll tell you mine later. So we have protocols in the military. In the health sector, we may have things like procedures. Yeah, but at the end of the day, all of these are simply algorithms. For programmers, we distinguish the set of instructions meant for the computer to execute as computer algorithms. I'm sure you have heard of this saying that garbage in, garbage out. So it is important to note that your output will depend largely on the set of instructions or the processes that you took or you used. So bad algorithms will definitely result in bad outcomes or outputs, like in this. You see that? So what makes a good algorithm? Well, we can take note of the following to ensure that you have good algorithms, right? So let's go to the screen. Now, first of all, your algorithms must be finite. We don't want to end up in an endless loop. Therefore, your algorithms must have a clearly defined beginning and an end, and they must end after a defined set of steps. A good algorithm must also be concise. No beating about the bush, right? So each instruction in your algorithm must be clear and unambiguous. Unambiguous. Ambiguity. I like the word. Thirdly, a good algorithm will always result in a one-of-a-kind solution. So if I follow your algorithm 100 times, I should get the same result 100 times. And lastly, good algorithms are effective. This means that the algorithms do what they are intended to do in the intended time, and so should yours, right? So then how do we write good algorithms? Well, in general, we have three main ways of representing algorithms. Firstly, we have what we call natural language algorithms, which we also refer to as NLAs. We also have flowcharts, and lastly, we have pseudocodes. So now let's explore each of these algorithms in detail. Let's begin with natural language algorithms, also called NLAs. Hey Siri, What's the best team in the world?
In 2021, Barcelona were recognized as the world's best club also for the second decade, 2011 to 2020. This is from wikipedia.org.
Thank you, Siri.
You're welcome.
Yeah, fantastic news for the Barcelona fans, for the coolest out there, yeah, but we move, right? Okay, but this is an extreme or an advanced form of natural language algorithms, also referred to as natural language processing. That's not what we're talking about here. So now let's look at what we really mean by natural language algorithms. Let's get to the screen. Natural language algorithms are the type of algorithms we write using regular language expressions. So to bring it down further, you just write these algorithms using a regular English language, just like the ones you normally see in things like recipes and the rest. So let's look at a typical example. So do you know how to find out your mobile number? Okay, so let's look at how we can do that with MTN. So to find out your own mobile number on MTN, you can follow these steps. So the first step, you dial *156#. Step 2, you select option 1 for check my number. Step 3, once that is done, you get a confirmation message that will come back to your phone displaying your mobile number. So if you see any kind of instruction in this format, you can refer to that one as a natural language algorithm. Now, can you try to write an algorithm for adding two numbers using just regular English language? Can you even translate that to your local dialect, like Zoma, Chi, or Fante? If you're watching me from outside Ghana, let me know some of your local dialects, right? Or like to know from you as well. Okay, to add two numbers, we can use this algorithm. So we start. We accept the first number. We accept a second number because, of course, if you want to add two numbers, you need two numbers. So you accept the first number, you accept the second number. Then you add the first number to the second number. Then you display your result. After that, you stop. Now, in this algorithm, you can notice that we have a start and a stop over here. And that should take you back to the properties of algorithms where we said your algorithm should be finite. So we have a finite. The finite means that they should have a clear beginning and an end. That is why we have these ones here. Okay. But you also saw that the steps should be clearly defined. But you can see that in this algorithm, they are not numbered. So we have just bullet points here. So the proper way to write this algorithm would be to number them, as you can see in this second solution. Right? So we have number 1, you start. Number 2, accept the first number. Number 3, you accept the second number. Number 4, you add the first number to the second number. Number 5, display the result. And now number 6, you stop. So now looking at this algorithm, you know that in 6 steps, you'll be able to add two numbers and display the result, right? Okay, so in a case of oral communication, it would be for you to just speak out the result. Is that all right? Great. Now let's look at pseudocodes, right? Pseudocodes. So pseudocodes are another way, or pseudocodes are another format that we use to represent algorithms, okay? In simple terms, they are just simplified versions of natural language algorithms, but they are more than just that. So let's look at pseudocodes in detail, okay? Well, pseudocodes are concise natural language expressions combined with programming logic, but with no specification to a particular programming language syntax. Right, that sounds like a lot, but let's break it down a little further, okay? Yeah, so in the last example where we wrote an algorithm to add two numbers, you can clearly see that it is a pure free-flowing English language, right? But in a pseudocode, however, this will look much simpler. So let's have a look at that. So you can see that we have the same 6 steps. We also have the start and the stop as well. But then you can see that most of the sentences that we had in the previous example have been trimmed down. So in step 2, instead of saying accept the first number, we now have accept N1. And then instead of saying accept the second number, we now have accept N2. And then instead of writing add the first number to the second number, we have a simple equation here. And we are saying result equals n1 plus n2. Display the result is the same, except that we now no longer have the there over there. So we just have display result. Right, so the N1, N2, and the results have been color-coded to illustrate certain programming concepts. So the N1, N2 here are what we refer to as variables or containers in programming. Okay, so in programming, we say that before you take any input, you have to declare containers, or you have to create containers where you are going to store them. So in this example, we are saying that we are going to accept a certain number. When we accept the number, we are going to store it inside a memory location called N1. And that is what the N1 there refers to. We do the same for N2. Now, in step 4, we know that if we are adding two numbers, then we are performing some sort of calculation, okay? So we say that if we perform this calculation, then we want to store the result in another container or variable called result. That's why we have that calculation over there. So we say N1 plus N2, and then we put that result, the outcome of that calculation into another container called result. Of course, you can use any variable name that you want. For example, accept num1, num2, any other variable name that you want. When we start doing C++, we are going to go into details what variables and declarations really are. But for now, it's just an abstract overview of what these things do. And then in step 5, we say display. But what are we displaying? We are displaying the result from step 4. So you remember that we did some calculation, and then we put the result inside a container called result. So we want to fetch the value that has been stored in that results container. That's why we have display result over there. And now we stop. Okay. An alternate solution to this one will be what you have on this slide. So here you can see that some of these words have been capitalized, and then the other ones are still the same. So stuff like start, accept, display, and the stop have been capitalized. We call these ones keywords. So keywords are special words in programming. They have special meanings and special functions. Okay. So each of these ones are going to have a direct representation or interpretation when we start doing a programming language. So for example, to indicate start in C++, we'll use something like the int main, because the int main function is the entry point of a C++ program. Okay. Even though some programming languages do not really have or have an indication of the start, we have it clearly defined in languages like C++. Okay. And then the accept. So we have accept in Python. We can say we use input to take to accept or to take input from the user. So we call the accept an input statement. Okay, so you can also use things like accept, input, read. All of those ones, you can use those ones to represent the input statement. Okay, but you can see that in the calculations section, everything remains the same because these are just names of variables. They are not keywords, so they remain the same. The display here is an output statement. So alternative keywords you can use for output statement when you are dealing with pseudocodes, output. You can also use print, and then you can also use write. Yes, and just in case it has crossed your mind, for start and stop, you can also say begin and end. All right, so let's do a quick exercise. I want you to write a pseudocode for finding the average of 3 numbers. Okay. Assume that the variables we are going to use are N1, N2, and then N3. So the question will be, are these all the variables we need? Are we going to need more variables? Are we going to need more containers? Let me know what your solution is going to be. So I'm going to pause here for a minute before I give you my result. So now this is how you're going to have to do it. You can have variations, but technically they should look similar to this. So you have your start. In step 2, you're going to accept N1, N2, and then N3. Of course, you can break these ones down into 3 steps. So you can have accept. In step 2, you can have accept N1. Step 3, accept N2, and then accept N3 in another line subsequently. Then after that, you're going to calculate the average. You know that to calculate average, you have to find the sum of these numbers and then divide by 3. Once you are done with that, you are just going to have to display the average. And then after displaying the average, you are going to stop. So that is all for pseudocodes, guys. That is all for pseudocodes. All right. So now it's time for us to look into flowchart. Flowcharts are an interesting topic. So we're going to spend a little bit more time on flowchart, right? So let me take a drink and I'll be back with you shortly, right? Cool.